Integration is the opposite of differentiation. Okay, so this is what sometimes it's not ideal to do it straight after differentiation because people get mixed up. But in some ways it's better because you just sussed out how to differentiate something. So now we're just going to go in reverse. Okay. So what do? Well, we're going to add 1 to the power and divide by the new power. Because if you recall, if I was to differentiate x to the power 4, what do? We multiply by the power and we take 1 off, yes? So this would have become 4x cubed. So if we would have this and we need to get back to this, we would add 1 to the power and we would have to divide by that new power. Okay? Does that make sense?
Yeah.
Tracy, yes. So, example here. Find y if divided x is 2x. So, y would be 2x to the 1 plus 1. So 1 plus 1 is 2, and the 2's cancel out. Easy peasy lemon squeezy. Now, this bad boy here, it's called the constant of integration. I would hope that you would never lose marks for not writing it, but let's not test that theory at all, please. Okay? So when we are integrating, you must write plus c. I'll explain why in a second. So here we go. Find y if divide x is. What would we do? We would have 3x to the power 3 over 2. 3 over 3, new power. They cancel, we just get x cubed. Trace counts. Yes? Next page. Believe. This expression here, okay, so this is y. I want to find dy dx, so let's get our heads back to differentiating. So differentiating this expression here, what will I get? Cameron?
2x plus
2x, okay. And Trishna, this one?
2x.
Olivia, this one? Do we see a little bit of pattern here?
No. They're all 2x.
So our derivative is all the awful thing is that was recorded. So the derivatives here are all 2x. So if I had said to you, can you please integrate this? My answer could have been any of these 3. You all see that? Yes? Because we know that constants just disappear. Alright? And so that's why you must always have that plus c.
So you wouldn't need to know the value of the c?
No. In some questions you have to find it, okay, but for general questions you just leave it as plus c. Okay? Because there could be a constant we don't know. Alright? Okay, so dy dx. So we've got this. Let's integrate it. So what did we say we would do? 2x over 2. Nice. Plus c. Oh, here we go. This is where it gets a bit trickier. Because it's over your original power. Sorry, it's over your new power. Sorry.
Wait, so you differentiate it first?
No, we've been told the derivative, and we are going back to the original. Okay? So that's what you've always got to remember. So you've been told the derivative, and they are asking you if they're integrating it, they want to find what the original function is.
Would that be 5?
No, so this says this. Okay, that's what that says, just in case you can read it properly. So the rules still apply. We add 1 to this. So it's going to become 1.5. Now, with, if you remember with calculus, with differentiating, we try and think of improper fractions rather than mixed numbers or decimals.
3 over 2.
So this would be 4x to the 3 over 2. Okay, and then we're going to divide by what? 3 over 2. Okay, here's...
For A, so we're just going to leave it like that?
Yeah, that's it. That is the answer. Yeah?
Wow, so sad.
So we've got 4x to 3 over 2 divided by 3 over 2. Now what's the rule when we divide by a fraction? We reciprocal. Multiply that's reciprocal. Shows the ends. So we've got 4x to the 3 over 2 multiplied by 2 over 3. Yes, because the reciprocal of 3 over 2 is 2 over 3. Now, 4x to 3, we're going to imagine that's 4x to 3 over 2 over 1, because obviously we've got fractions involved here. So this is going to become, what? A, sorry, to the 2 over 3 plus c. So not much of c there. Alright, so whilst the fractions look trickier and they aren't as nice, aren't as straightforward, the rule is the same. And 1 whole 1 to the power divided by the new power. If you've got a long expression here, okay, you just differentiate term by term. So 6x squared, what does that become?
Plus 4 and 3. No, that's
3x squared over 2. Now, secretly that this one was this one up above. Okay, so we can just write, take away 8 over 3 or 8x 3 over 2. Yes? That's obviously, yeah, oh nice, check it off. I wasn't going to write it there, but we totally can. The only reason I wasn't going to write it there is because I can do some simplifying here. Okay, and I know that 6 over 3 cancels out to just be 2. But the rest would be as they are. Now, notice I'm mixing it up, how I'm writing it. So sometimes I've written 3x squared over 2. Underneath I wrote 3 over 2x squared. They are exactly the same terms. They're exactly the same as each other. But they are written in slightly different ways. So I just want you to realise that if you have something that looks like this, then you could write it like this, and vice versa. Shelter?
Is the C always positive?
Well, no. You always write plus C, but the number could be negative. Yeah. So the answer is no, it's not always positive, but we always write just plus. Okay? We good? Okay, the integral sign. So we know that if we see an expression that says y equals blah, 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 and it says find dy dx, we know that that indicates that we're going to need to differentiate. Well, we need a sign to show us that they want us to integrate, and that's this big stretched out S. Okay? So this sign here, this symbol here, means we're integrating. This is what we're integrating. And the dx is written there because it's telling us to integrate it with respect to the letter x. So for example, if I had something like this, if I have this, I've got my integral sign, I've got 5g cubed, then it would be written dg here. Because I'm integrating this with respect to g, okay? So essentially this part and this part have nothing to do with the question itself, it's just telling you to integrate. Does that make sense?
So the question.
So this is now starting to say. So the integral sign and this end part, the d, just tells you what you're actually doing. It tells you you're integrating it. This one up here had the integral sign and a dx because my expression here was to do with x's. This one I wrote 5g cubed, and so the thing here would say dg. If you had 17p to the power 4, you would say dp. Okay, so whatever the letter is here is what's going to be attached with the d. But whatever that is doesn't make a difference. That doesn't affect what you're doing. The process itself is that you're integrating. Okay? So, find the integral of x power 1/3 plus 2x squared. Anyone? X to the 4 over 3, nice. Over 4 over 3. Because adding one whole one, remember? Plus 2x cubed over 3. I'm going to do that in a second. Now, I'm putting equals because this is a bit messy. So what happens when we're dividing by a fraction? Multiply by its reciprocal. So this is going to become 3x to the 4 over 3 over 4 plus 2x cubed over 3 plus c. Okay? The next one. So this one's a b. Okay, so this one's got an integral sign cb. Makes no difference. They're not always in brackets. Okay, so this is another thing to recognize. They're not always in brackets. It might just have the integral sign, the expression in db. So 7b, what would that become?
B squared over 2.
Oh, shit, Camerona out. Next one.
B cubed over 3.
Plus b cubed over 3. Oh, here we go. What happens here?
You're going to
Yes, yeah, what you said? Minus 3b. Because secretly, what is the power of b here at the moment?
1, 0.
So secretly at the moment it's 0, isn't it? Yes?
I would say maybe minus from the B.
Hey, so secretly when I've just got minus 3, I could have written, oh, serious thinking now. I could have written minus 3b to the 0. Okay, I wouldn't, but you could too. So our power at the moment is a 0, so it now becomes a 1. And obviously when you divide anything by 1, it stays the same. So I don't need to do the whole divided by 1. Chelsea, the bit.
No, you got me down.
Yeah, good. I can't do any simplification there, so I can just plonk my plus c on the end. Okay? Right, this next one here, we've got 3x plus all this fancy pants is over x squared. So when you have a fancy pants fraction here, what's the best thing to do first?
Fraction, but take it out of it.
Well, take it out of it, how? No, not factorize.
Get rid of the fraction?
No, not get rid of the fraction, but we would actually separate the fraction. Okay? So my question would now become 3x, and then we have plus root x over x squared minus 2 over x squared. Okay?
Not the fraction.
Oh, no, you don't need to. You can do it, but you don't need to.
So it's minus 2 over x squared, not minus 3?
No, it's just take away, because this take away is belonging to this expression here.
So not to the 2?
Not really, kind of. It just goes in front of that last term.
So you just integrate when you're just trying to find before the differentiator happens?
Yes. The original.
Oh, yeah.
Okay, now, we can't integrate yet, but I've got square root signs. I've also got fractions, and remember the rules when it comes to differentiating. We don't ever differentiate something that looks like this. What do we have to do? We have to rewrite it. Don't forget. So we are going to rewrite this again. So our question is still got the integral sign, so we haven't done anything with it yet. We've still got 3x, because that's sitting there on its own. Now, root x. How do I need to consider root x?
X half.
X, nice. X power half. Now, we're using our laws of indices here. So when we have x to the power of half over x to the power squared, or the power 2, what's our rule? If you were squaring this one, then it would disappear. But if you've got x to the half divided by x to 2, what do we do with our powers? We subtract. So we're going to have 1/2 subtract 2. What's 1/2 subtract 2? Negative 1/2. Okay, so we've got plus x to the negative 1.5.
Yes, that's what I said.
Sorry.
That's what I do.
I heard the negative.
That's a 3. That's a 3.
That's 3 over 2.
Okay. Can you just
totally good then. No. It's one. And then what would I do with this last one? 2x to the negative 2. Alright, so still haven't done anything to my question other than rewrite it. Now at this point I can now start integrating. So I don't need to any longer write my integral sign. Okay? So 3x, what does that become when we integrate it? 3x squared over 2. We're loving these ones, aren't we? Now here we go. We've got x to the negative 3 over 2. So we've got plus x to what? What's 1 added to negative 1 and a half?
Negative 1/2.
Negative 1.
Negative 1/2.
Negative a half. What do we have to do with that? We have to
Over 1/2.
divide by negative a half. Okay, minus 2x to the, what's 1 added to negative 2? Negative 1 over negative 1. We can write the plus here if we want, we can write it at the end, makes a difference. Here we go. So this first term is fine, we don't need to do anything with that. That's just 3x squared over 2. Now, we have here plus this divided by a negative number. So if we've got a positive thing here divided by a negative, what's going to happen to the whole thing? It's going to become negative. So this sign is now going to become a subtractor. Okay? If you're dividing by negative a half, you're going to be multiplying it by, what's the reciprocal of a half? Multiplied by 2, so it's going to become 2x to the negative a half. Was that too quick?
Yeah, very.
Oh my god. Alright, well let's leave it like this then. We'll plus negative 2 over 1 x to the negative a half. How about that? So I've gone from being negative 1/2 to negative 2 over 1, and I'm trying to help.
So it doesn't really need to be over 1.
No, but I'm doing it just because people got stressed when I just wrote 2.
I thought the reciprocal, if it was a negative originally, doesn't
Oh.
opposite.
No, so that's when we're, so this is where we've got parallel and perpendicular things. That's when you've got the negative reciprocal. This we're just multiplying by the reciprocal. Okay? And here we've got take away, no, if you've got 2 divided by negative 1, what's going to happen here?
Negative 2.
And so you're going to have plus 2x. Because these 2 negatives here,
I see. Got it.
yeah? And so our final thing, which some people may have been happy writing the line before, is this. Okay? Because obviously these signs here became a negative, and obviously we can get rid of the one. Oh, sugar.